This video addresses a few questions in the Intro to Nucleophilic Substitution pre-lab. So at this point, we have our carbocation intermediate here, but let's go through what has happened so far in our reaction. So we had OH here, and that is not a good leaving group, so we protonated it to make positively charged water, and now that is able to leave. So I'll mark that over here. This is our leaving group, which after it leaves, it no longer has a positive charge, but this is our leaving group. After it is left, that leaves us with a carbocation intermediate here. And one of the questions on your pre-lab, oops, I have the answer there, but one of the questions on your pre-lab asks, is this a stable carbocation? So in order to do this, I like to isolate the important part because we have R groups attached, which are important, definitely, but for this question, all we really need is our carbocation intermediate, which I've drawn over here. So this is our electrophile, and this is our nucleophile. So you might have seen before, I said, yes, this is a stable carbocation, and here's why. When I look at this, I see that the central carbon is attached to 1, 2, 3 carbons, making it tertiary. We know that tertiary carbocations are very happy in this position. They are very stable compared to primary, secondary. Those carbocations like to attempt to rearrange if possible to become more stable. So tertiary is the most stable. So yes, this is a stable carbocation because of that tertiary position. Another question on your pre-lab asks if Sn1 or Sn2 is more favorable for this reaction. And in order to figure this out, we can look at the diagrams given to you in the pre-lab. It asks you to choose the correct mechanism and show the arrow pushing pattern. So for Sn2, we have our leaving group here. I'm backing up a little bit. And our nucleophile, which is negatively charged chlorine in this case, that negatively charged chlorine, our nucleophile, will attack at the same time as our leaving group will leave. So there is no carbocation intermediate. But in our reaction, we know that if the leaving group leaves, we form a stable tertiary carbocation. And in Sn1, that's what happens. The leaving group leaves first. This is our leaving group. The leaving group will leave, form that tertiary carbocation, which is very stable, and then that nucleophile can come in and attack that carbocation. So Sn1 is more favorable because it can work with a tertiary carbocation and form that intermediate, whereas Sn2 does not form a carbocation intermediate and primarily works with primary and secondary carbons. So Sn1. Hopefully this video helps you, and make sure you ask your TAs if you have any questions.